Welcome to Assembler, an easy AR instruction guide to assemble furniture. We are team number 6. First, we want to talk about the impact of our project. So the figure on the left shows the ongoing complaints about assembling furniture from IKEA, and the chart shows the top 8 most frustrating furniture to assemble. We can see the completion rate only range from 15 to 70%. And the animation on the right really shows our ideas that we want to create a AR tool that can guide users to build furniture. Furthermore, we identified 3 potential impacts. The first one is that the assembler can significantly reduce the number of returns by giving the customer a better understanding of how a piece of furniture will look in their space. Second, it is very eco-friendly because sometimes incorrectly assembled furniture can cause damage to the pieces, leading to a waste of materials and resources. Assembler can effectively prevent this situation. The last one is we bring innovation in retails. So by utilizing assemblers, customers can get hands-on experience with assembly processes right in the store. We will also want to talk about novelty of our application. So as you can see, the newest IKEA virtual app only shows the contour and overall look of the furnitures. It has no helps and guide that can help customers to assemble their own pieces. So in our applications, we actually designed 2 innovative interaction methods to guide users' interactions. With further user studies, we can understand our system's usabilities. And Yukon will dive into details about how we implement these interaction methods.
So let's dive into the implementation part of our project by quickly reviewing the storyboard and structure of the application. So our application assembler mainly serves as a platform in which you learn to assemble furniture, and our demo a table under detailed guidance. You will mainly use your virtual hands to grab and place pieces to the right position to assemble the table. And you can also use the UI to go back or skip steps. So before we watch the video, it's well worth to note that our 2 main features for user guidance. The first one is UI instructions, which means the user can refer to a UI for guidance and go back or skip steps as they want. The second one is the highlight instructions with ghost objects. So next to the table pieces, there will be a ghost table to help the user to put different pieces in place with the corresponding objects highlighted. Now, let's see a quick demo of our assembler. So as soon as you enter the application, you will see a home page, also with the ghost table and also the table pieces by your hand. By pressing the start button, it will lead you right to the first step of the assembling. The user can go through the assembling process freely by clicking the next button, as well as go back by clicking the back button. The assembling mainly requires you to grab the highlighted pieces to the right ghost position, which is also highlighted. The UI will also dynamically change according to your assembling progress. And as you can hear, there are also special audios once you finish a step or click any buttons. After you finish all the steps, there will be a simple congratulation page, but you can also choose to go back to the previous steps by clicking the back button. Yeah, that's pretty much the implementation and demo of our project. We can see the UI and the highlighted ghost objects can both help the user through the assembling progress, as we'll talk about more details about them in the user study part.
After conducting the user study, we noticed that one of the main difficulties for the users was placing the object at its shadow position, as it didn't seem quite clear to them that the overlapping of the object was the main process in order to get to the next step, with some users suggesting to make an easier version of this shadow position, and also considering having it more accessible to the target objects. One of the main goals of our study was also comparing the UI and the highlighting methods as a mean of guiding the user to the next step. So we conducted a paired t-test significant analysis, and it showed no significant difference between the two methods. However, we must consider the size of our study with only 13 cases, which is not enough to give us a potential difference between the two, especially because the two methods scored quite high. But we can see a clear difference in the mean, with the mean of the UI being significantly lower than the highlighting method, suggesting that our highlighting method was preferred. Also, upon observing the users, we noticed that they tended to more easily use the highlighting method instead of each time needing to look up towards the screen to figure out what step and how to implement it. Finally, some of the positive feedback we got on the implementation was that a large number of users confirmed that the highlighting method was their preferred feature in our implementation. Also, a lot of positive feedback on the audio and visual feedback from completing the steps. The automated step procedure once the item is correctly placed, and also having a 3D visualization of the final product as a mean of understanding towards what the user is supposed to get to.
This is Jiahao. I never talk about the future work. In the future work, there are many things we can do. Let's take a look at this picture on the slide. This is our original UI interface, but ultimately we decided to remove it due to the short duration of the quarter. We could only complete the assembly of the table within the limit time. And in the future work, we hope to introduce more assemblable furniture, such as chairs, bookshelves, and beds. Apart from assembling furniture, our project can also make contribution in the entertainment area, such as Lego toys, like showing on the picture. And most Lego toys consist of hundreds of pieces for assembled. And our project can work well in this regard. And it can eliminating the frustration of not understanding the instruction manual. And in our future plan, we will enhance the user experience with improving the UI in the future. In previous user study, some user mentioned that the UI and the shadow model were too long. Therefore, we have two plans for the future. One is design the UI to follow the camera's movement using a gesture to target the UI, and the other plan is involved in placing the UI on the user's hand. When the hand is spread out in front of the camera, the UI will be displayed on the hand, make it more convenient for user to interact with the UI. And this is our final presentation. Thank you.